going to do here is explain moles here. So you're not super confused. But if you remember, a mole, 1 mole, is 6.022 times 10 to the 23rd particles. You do not need to know this number for the reagents, this number here, Avogadro's number. But what you are going to have to understand is when you go to the periodic table and you look at the gram formula mass or molar mass of an element, that is equal to 1 mole. So I'm actually going to address that after I go over these problems here, 1 through 7. And we can talk more about it in the Google Meet tomorrow. But I do want to explain how do you go from grams to moles, right? Because that, if you look at the bottom of that worksheet that was due today, 8, 9, and 10, you have to do that. So I'm going to have to teach that. All right. So here we go. So I'll come back to that. All right. So number 1, molarity of 0.3 liters, 0.5. So molarity, this is molarity. So that's M, capital M. And that's what I'm solving for number 1. So X goes here. X equals, they give me the moles, 0.50 over 0.30. So this is my moles, this is my liters. And then, so when I divide those, right, so I'm kind of doing this as I go here. I didn't do it yet. 0.5 divided by 0.3, I get 1.666667, right? So 1, 2 sig figs, 1, 2. So if we round this to 1, 2, right, that's the rule, to the lowest number. So that would be 1.7, and you can do capital M or 1.7 moles per liter. So that's the answer to number 1. Okay. Number 2, same formula the whole time here. Calculate the molarity of 0.289 moles. So that goes on top. And then 120 milliliters. So we have to convert that to liters, right? So 120 milliliters. If we take the decimal 1, 2, 3, that's 0.120 liters. All right. So again, we're calculating for molarity on number 2. So X equals, and the moles would be 0.289. So that's 3 sig figs divided by 0.120. That's liters, that's moles. That's number 2, question 2 here. All right, so if we divide these, so we get 0.289 divided by 0.120, and I get 2.083, so 2.4083, so 2.41. 3 sig figs, 3 sig figs. Again, capital M or moles per liter. Either one is the unit for molarity, and that's what number 2 is asking for. Okay. Number 3. So number 3. All right, if 0.075 liters contains 0.0877 moles of CuCO4, what is the molarity? So for number 3, now we have, more of the same. We're looking for molarity. X equals, so the moles are 0.0877 over the volume, which is 0.075 liters. So that's liters, that's moles. We don't need to convert. That's already liters. So all we do is divide those two numbers. So if we divide those two numbers, 0.0877 divided by 0.075, I get 1 point, and let's see, 1, 2, 3, 1. So we have 2 sig figs here. So if we're following the sig fig rule, this only has 2. So 1.169, so that's 1.2 capital M or moles per liter. So that would be number 3. All right, number 4 now. How many moles of NaCl are present in 600 milliliters of 1.55 molar NaCl solution? So when you see, so here, let me zoom in here. All right, so right here where it says how many moles are present and 600 milliliters of 1.5. So that M is molarity. The way we say it is 1.55 molar NaCl. So that's kind of the terminology. Molar means molarity. So, so here we go. For number 4 here, we have molarity, we have the volume, we're looking for moles. So let me go back to this. So they gave me, for number 4, they gave me, let's see, 600 with a decimal at the end, milliliters, and they gave me 1.5 capital M. We are looking for moles. So we're looking for that. They give us the molarity, they give us the volume. This is actually 1, 2, 3. This is 0.600 liters, and that is the molarity. So I plug the liters in here, molarity here, solve for moles. So 1.55 equals X over 0.600. This is really over 1, so I cross multiply. 1.55 times 0.6, and X equals, and we have 3 sig figs, 0.930. So on my calculator, it just said 0.93. I have to add a 0 to give me 3 sig figs. And that's moles. So that's M-O-L-S or M-O-L-E-S. You can abbreviate it or not. Doesn't matter. So again, you can write M-O-L-S. That works too. All right, so that's number 4. All right, number 5 now. All right, number 5. How many moles of H2S? So here, I'll go back to this. How many moles of H2SO4 are present? So this time they give us liters and they give us molarity. So again, just like number 4, they give us the volume, they give us the molarity. So for number 5, we have 1.63 liters and we have 0.954 for the molarity. Again, how many moles? So we're X on top, same thing as number 4. So we have 0.954 equals X over 1.63. This is really over 1, cross multiply, 0.954 times 1.63, and X equals 1 point, and again, 3 sig figs, so 1.56, because this was on my calculator 1.55. It was this number, 1.55502. That rounds to a 6. That gives me 3 sig figs. Label unit, circle, or X, or box it. That's number 5. Okay, number 6. All right, how many liters of solution here? Again, I'll go back so you can see it. Number 6, I didn't do that on the first couple. Sorry, guys. Number 6, how many liters of solution need to make? 1.66 containing, so this time they give us moles and molarity asking for liters. So for number 6, they give us 1.66 for molarity, and they give us 2.11 for moles. So they give us molarity, they give us moles, they're looking for how many liters. So that's going to be X. So molarity is 1.66 equals, moles goes where moles goes, 2.11, and X goes for liters. This is a little bit harder with the math. You have to cross multiply and then divide, right? This is over 1. So it's 1.66 times X equals 2.1. Divide by 1.66, divide by 1.66. Sorry, I'll put the answer here. X equals 2.11 divided by 1.66, and we get, hold on, what happened there? 2.11 divided by 1.66, and we get 1.27 liters. See, sometimes I even forget what we're solving for, right? So it's always good to write down what we're looking for, right? I'm looking for liters. So when I got my 1.27, I was like, what am I doing here? They gave me moles and molarity. Always write down or go back to the question. Say, what am I solving for? Because then you know the units. I'm solving for liters, so that's how I know it's L. 1.27. All right. And number 7. And then what I'll do is stop this video and post it, and then explain how to do grams to moles. And I'm going to give you actually some practice problems, a worksheet on converting grams to moles and moles to grams back and forth so that you can do problems 8, 9, and 10. We'll make that due like Wednesday. and then we'll do colligative properties. All right, so here we go, number 7. All right, what do we got for 7? What volume of 0.25 molarity or molar can be made using 0.55 moles of CaOH2? All right, so they give us moles, they give us molarity, they want to know volume, which is liters, right? In this molarity equation, right at the top, volume is liters, must be in liters. Okay, all right, so here we go. 0.25, they give us 0.25 for the molarity, and our moles is 0.55 moles. Again, we want to know liters, which is volume. All right, so X goes there. Molarity is 0.25 equals 0.55 moles goes on top, divided by X again. This is over 1. 0.25X equals 0.55. Divide by 0.25, that cancels. Divide by 0.25. X equals 0.55 divided by 0.25, and I get 2.2 liters. So that's number 7. So if I went a little fast with some of these, I apologize, but I'm not even keeping track right now. I'm trying to keep my videos, like I say every time, kind of shortish because I just think that's easier for you guys. But you can always pause it and then see what's going on here. But I really need you to check your answers, because this isn't like normal school where we're all in class and I can do it with you, and that's ideal, right? But so it's on you guys to really check your answers here. That's why I'm doing this. All right, let me kill this video and then I'll come back on another one.